Alright, so now for part 2 of chapter 3, we're going to talk about trig a little bit. So if you really want a good little encapsulation of a trig review, go out to openstax.org, and OpenStax is OPENSTAX.org, and grab their pre-calculus book. It's free, it's a PDF, or you can view it online. Doesn't matter which you do. And chapter 5 of their pre-calculus text is about all you really need to know for trigonometry for this course. So it's just a little slice of what you would normally have in a trig course, and it really comes down to just a few things, right? If we have this angle t over here, cosine t is the adjacent side over the hypotenuse, right? Sine t is the opposite side over the hypotenuse. Tangent t is the opposite side over the adjacent. It's simple, straightforward. This is the very basic start for trig that most of you have had, and learning these functions. Again, if you want a really good review, head out to that pre-calculus text. But these are the basics. We're going to use these over and over and over again. You'll figure out how to use them on your calculator. We'll talk about, you'll need to be careful about making sure you understand, is your calculator in radians or is your calculator in degrees, the two different methods for using the angle there with most calculators. If we put it in more standard terms like we do for the Pythagorean theorem, A, B, and C, then cosine theta is A over C, cosine theta, sine theta is B over C, and tangent theta is B over A. Pretty straightforward so far. And in the Pythagorean theorem, a squared plus b squared is c squared. Well, guess what? We're going to divide by c squared here, and a over c squared plus b over c squared equals 1. Well, that's just cosine squared plus sine squared is 1. And that's one of your trigonometric identities they gave you, right? That actually falls straight out of the Pythagorean theorem. Finally, when we start talking about the inverse tangent and the inverse sine and the inverse cosine, and we write it like this, tan to the minus 1, that is not 1 over tan A over B, right? So when I write x to the minus 1, I'm raising x to an exponent, and that is in fact 1 over x. But when I write tan to the minus 1, I'm saying I'm taking the inverse tangent function. And for most of you on your calculator, you hit like the second key in tan, and you'll see the tan replaced by either tan minus 1 or a tan. All right, it's another way we often write it with calculators. It's left over from Fortran, a programming language. A tan, a sine, right? This is the inverse a cosine. We have these terms because, you know, the programming language Fortran used a function called a tan to calculate the inverse tangent. Now, and there's some issues you have to watch out for with the inverse tangent in particular. All right, so the sine and the cosine are periodic once over 2 pi, but the tangent is periodic twice over 2 pi. So whenever you take the inverse tangent, there are two possible answers, right? But your calculator is only going to give you one in, all right? There are two possible answers. Your calculator is going to give you the one that's over here. Sometimes the physical answer is over here, all right? If this, let me draw that again. If this is the x-axis and this is the y-axis, all right? Your calculator is always going to give you an answer that's in positive x territory. But sometimes, if you're talking about a function or an angle that ends up over here, all right, your calculator is going to give you that answer when what you're after is this answer, this the physical one. And it really comes down to, let's look at this inverse tangent. It's a ratio, right? It's a ratio. So how is your calculator supposed to know the difference between, and yeah, you could write this function in computer programming, minus 1 over 3 and 1 over minus 3. All right, the answer is your calculator can't tell the difference between those two ratios because the ratio is exactly the same. All right, they're both minus a third. So this is the source of that confusion. That's why whenever you use the inverse tangent, you have to actually think about the answer and think about what's physical. All right, so that's it for our very quick trig review, and we will move on to two-dimensional kinematics finally.